stream. It's
There we go.
preparing.
Oh, there it went.
There it went. It's funny
Comedians
how
being
it
screamed.
it's funny how it goes live like that, but like right now on my screen it says setting up your meeting. This is
Well,
how
which
I
is it, Zoom? Which
this
is
is
it?
how I get in
Oh,
trouble.
there it went. Oh,
It's
and
funny.
there's the voices.
Yeah, I'm gonna close
And
that so
see
it
it
doesn't.
as soon as I get that notice from based on when I'm talking, at least, that's when it goes live too.
Yeah, it's the delay is interesting. So that's where I gotta watch my potty mouth.
Yeah, I mean, we didn't say it was rated G, did we?
No, we didn't. We didn't. We
And
didn't.
to my
But
knowledge, everybody laughed.
yeah, so it's good. I blame that on my many years of working in the auto industry
Yeah, I could see that being a place where people swear a lot.
all the
Or
time.
really just around people, I guess. Unless you're
Yeah.
in some sort of like sales business or something.
Yeah, the salespeople typically have to be more professional, but I worked in the parts department and
So
wasn't a
no,
mechanic,
no.
so no. It was just every other thing was an F-bomb. So I just started picking it up.
Well, hi anybody and everybody.
Yeah, hello. Welcome to our weekly live stream. If anybody is out there watching,
This is like number 6, I think.
yeah, I know we're on a roll. Uh, so today we're gonna discuss the current, I don't know, flares that happened, which ended up being kind of nothing. And steady magnetospheric convection events. So this is it'll be a little bit of a deep dive in some academic papers. And hopefully, you'll get something out of this because it um learning more of the nuanced dynamics of the Aurora activity is helpful for anybody chasing it. So anyway, hi Christian.
Hi. I'd say it's especially useful for anybody in, let's say, the latitudes, 45 to 55, those who aren't quite the aurora oval, but those who are just north enough to get the any sort of faint aurora on the horizon, because they're
Yes.
the ones that are going to be seeing the type of aurora more.
Yep, that's for sure.
Michigan,
Yeah,
talking to
Michigan,
you.
Michigan sees these a lot, and Minnesota's Minnesota and Canada. Well, our Canadian border.
Which apparently UMAC stands for Canadian border now.
Yes, Canadian border Aurora events.
Poor Tanya.
I know. All right, so I guess we can start with the flares. I brought up the Swipsy page, so maybe I'll just share it. So
I
share.
guess for the first time for our videos too, I don't have anything prepared as far as my screen is concerned, so I don't know if I need the screen share function for today.
Okay.
So
I'll share
I
it.
can rant in the meantime.
Rand. So you could see this, right?
Yes,
Okay.
AE
So
index.
yeah, we're at that's one tab. So let's go back to the
That
home
is
page.
one quiet curve.
Yeah, so this is the main page of Space Weather Prediction Center. It's not really any of their dashboards, but it just kind of goes over what's going on. Pretty quiet, but we look at here, we have the X-ray flux, and you can see where that X flare was right here. But it ended up being impulsive, didn't have anything associated with it. Didn't even have a radiation storm with it. You see on this tab here, the gross proton flux, it's flatlined basically. So it was all, what did they say? All bark, no bite.
Yeah, it was just a screaming child who didn't have any teeth yet.
Yeah, I mean, could we see more from it? Probably, but the it's rotating off of the west limb now, so the likelihood of it affecting us is slim, other than radiation storms. So we just got to wait for the next one. So part two of this is our um, they had a prediction up, or a not a predict but like a watch for a G1 watch yesterday and today, and people have probably noticed that nothing has materialized, but that's from a coronal hole, which you won't see on this anymore because it's rotated out. Last week we talked about this coronal hole, and we both thought that it wasn't going to amount to much of anything, and that ended up being true. So
What?
So yeah, no real activity, but we did have a couple of steady magnetospheric convection events. So that's kind of what sparred this conversation. So yeah, if you, I don't know, Christian, if you want to start it off, you can.
Yeah, sure. So, since we've had most of those, and I'm going to point it out to Sam's. Actually, okay, so maybe I can go ahead and
Yeah.
do some sharing because Samuel had a good post on believe it was UMAC or the Michigan group. I'm actually not
I
sure.
think he put it in multiple groups, so you probably could find it in either.
All right, let's check. I'm already in the Michigan group, so let's
But
see if we
it is a good example of studying magnetosphere. I'm eventually going to get that word right.
see. There's a reason we came up with, I guess, with the anagrams, because
Yeah,
now it's like
The SMC event,
way too difficult to say regularly.
but it's a good illustration of it and the types of features, or I should say, lack thereof, that you'll see with these types of events. So once he finds it, he'll bring it up, and
So
then
it's got it. So I will go ahead and share mine then. So essentially, steady magnetospheric convection. That's such a fun word.
it's a fun
I
word for something
never want
that's
to say it again. Um,
relatively boring.
if you're watching Sam at some point, hi, you had a good post for this,
Yeah.
so we're going to use it for this example. But
Yes.
super faint aurora, it's obviously there. Pink's in there. There's some green, but there's no real structure. He doesn't say how long of an exposure this is. I'd be willing to guess it was probably 15, 20 seconds, though.
Right. Yeah.
Long enough that some sort of structure should have been revealed from it. But nothing.
There it
Uh,
is, right there.
and this is generally what we have had as far as Aurora is concerned for many, many, many days now, outside of the occasional substorms that we've seen from. Actually, have we really seen any? I think I've seen a few in magnetograms.
Yeah, there probably was because one of the characteristic of the of a SMC is that it's triggered by a substorm and it ends with a substorm, which is interesting. So you should be able to find them even if they're a little.
Let's see. I was going to see if I could just pick to a random day. Oh, that's a quiet curve there for you.
Yeah.
Well, I guess if you're looking and ways to determine it too, I'm not going to pick a random day.
I
That's
think
probably
9
going to
and
be.
10, like 9 and 10 had some good um examples from what I remember.
Oh,
Because see
yeah.
how like you got the little humps there and then it like quiets back down. But
So this is fun looking at for the first time, at least in the AE index for them. I generally look at the magnetometers for the sake of whether or not we're having one, because usually they'll exhibit similar characteristics, being just small variations and
right.
usually at least the age component. But the idea is this is when there is an equal amount of day side reconnection going on with the night side reconnection, and this causes just a steady stream of energy to be released over time rather than it being in bursts like the substorms would occur or in big bursts like the sawtooth events would be. We get just steady, some lights here and there, but then never getting that much brighter, except for maybe occasions where there can be individual breakouts in individual areas of the night aurora. But outside of that, you're basically getting just the standard little glow that excites people that are into it for the first time or just into it for the sake of pretty photography. But if you're looking for actual aurora storms, it's really nothing to pay attention to.
Yeah, it's pretty lackluster, but it's interesting to say the least. I mean, all of this stuff is interesting and it's neat to actually like dive deeper into the structures of aurora, the different types of aurora because there are many types and like trying to figure out what leads to them and what ends them and stuff like that.
And
So
not only all of that, but then you've got the different connections with, SMCs can affect electron aurora and proton aurora differently. So you can
yeah,
usually tell based on those two what's going on and how far they've spread as to what the event is. But the more you know about any of this little stuff, the more you can add on to it, the more it makes it more reliable so that you can look at the data and figure out what's going on and maybe not be disappointed going out when you're looking for an aurora at 2 a.m. at latitude 40 degrees
yeah,
in
like
March of
you know,
2012.
you can catch up on your much needed sleep. So I will share because I put together a Word document. So let me show here. Do I want to do Microsoft Edge? Let me go to desktop because I want to do the Word document because I just dissected this paper. I mean, I tried to
I
because I
like that it gives you the option to just share whatever document or pages you have open, but
yeah. Um,
oh
I'm not
wow.
a I will say I am not a scientist and I tried to read these papers, but there's stuff in there that is above my level, my pay grade because it gets a little mathematical. So I tried to like pick out um things that I thought were interesting and maybe like more pertinent to some like an average Aurora chaser than some of the heavy mathematics that's involved with it. Um So this is kind of what I got out of this. I guess this is the original paper. So thanks, Tanya, for that, for finding that source. Because I think Christian's going to add on with some of these newer papers how some of these definitions might have changed because of our way of being able to track these things have changed a little bit. I mean, it got better basically.
It looks like a
So,
lot of the points you have written here, at least, are mostly the same from what I can
okay,
remember,
good.
other
Yeah,
than the actual. And again, the only real changes I noticed were for the sake of the algorithms and what they called SMC events rather
right.
than it being a formal definition.
Yeah, like the time intervals. Like this was minimum 4 to 6 hours, which is two times the substorm interval that is average at 2.7 hours. And then like you said, it's like the daytime and nighttime flux are equal basically. They can't, so it's stable. And it may be stable for 10 hours. So that's a long time. And then also there was an interesting paper about ring current involvement
Ooh.
that might contribute to the steady convection. I put a question mark there because I attempted to read this paper and it got very mathematical very quickly. So I need to go back to it. But
Send it to me. Not
yes,
that I, have the top level math experience there, but
it's very interesting because it's basically saying like an energized ring current can have an influence on making things steady, which is kind of neat. So we'll revisit that at another
I
time.
wonder if that gives any connection to subauroral stuff too, then.
Right. Yeah. So there might be more ring current involvement than we originally thought with some of this stuff too. And then the operational definition. This is now I think this is what's changed a little bit because of the algorithms, but their operational definition as of 1988. So this is going back
Ooh.
back a ways is a stable continuous southward IMF for more than 4 to 6 hours, typically -4 or less. So it's very little input. And then having the enhanced convection of AE of greater than 200 nanoteslas. And when we looked at that AE index, sometimes that can be hard to see because you got 0 and then 500, and then you have to like eyeball what's in the middle there. I'm sure there might be something else out there that breaks it down easier or better, but I just haven't
There's
found.
likely a text format that shows the
Yeah,
specific
that
numbers
shows
per
like the
hour.
steps. And then no substorm signatures. And then things like that. No large scale or this is more of the sciencey part of it. You could if you read it if you want, but
Mm.
no sheet disruption because they talked about the crosstail current. Like there's actually a pretty big injection or like electrical injection in the crosstail current, which was interesting. Um, and then I pulled a couple of diagrams here so you could see what I'm talking about.
Ooh.
So this like here it shows the A index. See that this is a great example.
1981.
This is a great example though, because remember how it says that it's punctuated by substorms? So you have this
That one substorm there,
and the one
and
over
the
here.
secondary
And then everything in the middle is very
SMC.
flat. And then this diagram, which is actually from a satellite, I think it was GOES 2. I mean, we're talking like old satellites, shows how the Aurora oval just doesn't really expand much at all. And it's very much the same, like all the way around. And that's kind of the point of this SETI magnetospheric convection is it's like an equilibrium basically. It's like
Yeah.
in and out.
No real expansion in the lower or upper
Yeah.
indices.
And then I pulled this diagram because this kind of shows
Mm.
like your typical substorm development when you have the reconnection in the tail and then it shoots the plasmoids back up. So you have your growth and recovery phases, basically is what's going on in an SMC event, but no expansion. So it's very, I thought this illustration was really cool because it's
That
like
is really cool.
it kind of shows like what's going on and why you're only seeing this very diffuse um arc basically because you're getting the the growth and recovery but no expansion until it breaks.
The ones
So
I looked at didn't have diagrams, at least specifically looking at the magnetic field. That's pretty cool.
yeah, so I thought these were the cool points of the paper. There was a lot of other stuff in there. Talking about the electrical currents and like I said, like I mentioned, the crosstail one and some other ones too. But I for this discussion, I figured that was getting a little bit
Probably
too much.
enough.
I mean, it's kind of still above my own understanding. It's like I'm still getting the magnetospheric part of it, but when you start talking the electrical currents, I get a little lost right now. So I need to go over that more. But
And I mean,
this,
that's just an exposure thing too. That's
yeah, like I just need to read more and just try to, really sit down and not get frustrated when it starts to get overwhelming.
what we decided this was going to be the topic, what, yesterday?
Yeah. And it was, it's interesting too because it challenges me to think a little bit more, going back to the academic days that I've been out of for so long. Um, and it's neat. And what else is neat is like none of this is out there in like a really digestible format. It's just not. Like if you try to Google steady magnetospheric convection, you're going to come up with academic papers. That's it.
Yeah, I don't think there's going to be an ability, at least right now, to have something that's a little less in the academic area and more in the just bluntly, layman's terms, I guess we'll say. I don't really know how I would explain this type of an event into a layman's beginner
Yeah.
way. Not
And
yet,
may,
at least.
and maybe that'll be some of our challenge as being like Aurora ambassadors and trying to really understand these academic areas and bring it where it's more digestible. But that's going to take time and practice. Like Tamitha's really good at it, but she's also been doing it for a long time.
And has way more background knowledge on all the subjects than
Yes,
most
and
people.
then
I
and
mean,
then any of us do.
yeah,
So
she's
for
the most
her,
qualified anyway.
yeah, she can break this stuff down and make it digestible. Like, whenever she came up with that slinky analogy, I mean, like,
So
it
many
was,
people use that now.
I know it's like it because it's just so it makes so much sense. And I'm a visual person, so that's why I actually pulled the diagrams because if I can see it in a more visual format, I can digest it better. Um,
I think most people would agree with you too. And I
yeah,
think that's Tani did something like that for to represent three-dimensional magnetic fields as well, or at
yeah,
least to get the idea of what 3D means, like something that's just visual that people can look at and see instead. I it helps, but I can usually just imagine stuff, and not to say it comes out the same way, but I don't need the visual aspect quite as much. And the only thing I want to add to going backwards, at least, I don't have anything to show for it, but the newer papers I read in SMC events, they've separated them a little more now into categories to where it'll be lower events where the AL index barely changes, and then you've got the standard ones that they call just the normal, but the AL index can actually change pretty radically during them within that 200 nanotesla boundary. And
okay,
so it's a little harder sometimes for them to get it. And then they actually looked, the paper at least that I was reading looked at how individual aurora, because they had access, there was a satellite that went around that had access to view the northern aurora for 18 hours at a time, and then both hemispheres, and then the southern for a while. So they've got a long period of days of just actual imagery of it. And then they went back and looked at data and da da da. But they were actually able to look at how the proton aurora and the electron aurora differed based on the type of event that was occurring,
that's
whether or not it was steady and whether there's a substorm beforehand and like a bunch of other different factors. But the idea is it all came to the same conclusion of SMC events are flux in equals flux out, and the aurora is generally not dynamic and fairly boring,
right.
like a standard proton aurora.
Yeah. Long story short, not dynamic, pretty boring. But from a scientific standpoint, pretty fascinating.
Yeah. Oh, yeah. And especially since we're now literally swimming in them, it makes it easier to find moments to connect them to, especially with all the photos going up of
Yeah.
them, being able to see the events on magnetometers and the AE index, and then going, oh, well, that's what it looked like. Yay for good cameras that pick up everything now.
Yeah, it's definitely been it's really cool. It's neat that projects like Aurorasaurus has really been embracing the citizen science because there is a plethora of data out there just by people going out there and photographing the stuff that scientists can use
Which,
to
on that note,
yeah
everybody that's
yeah
watching, or at least or has Aurorasaurus, check that out and post all your photos there.
yes yeah because that definitely it helps with all of it. It helps because the more data they have, the more they can plug into different algorithms, and it just gets better. Like for example, the ovation model, which misses a lot because it's but it's cool because it's there and it's something. But the more that we can feed these algorithms or the science, the better they're gonna get. So
Still better than KP.
Yeah, it's still better than KP. If you noticed, we didn't
by a
talk
little
about
bit.
KP at all with this because these types of little things that have are nuances in the dynamics of Aurora won't be picked up in KP. It just won't. It's kind of separate. I mean, I can't say totally separate because like it's all tied together. But if you're
Sure,
looking
but
for
it's a different result.
it's a different result. If you're substorm chasing and you're looking for specific things, you cannot rely on the KP index or don't even really look at it. You really have to start leaning into other things.
My
Um,
favorite 2 points for that, the Aurora A is different per latitude or per longitude even. So depending on whether you're in the dusk side or the dawn side, you could be seeing different things based on the same KP, but you also then have the biasim at Europe for the KP index to begin with. So if that's going to be on the night side, then you're going to see higher numbers than vice versa. So
yeah.
like tell me again which part of that helps describe it you see Aurora?
None. None
None? Cool.
whatsoever.
We're on the same page, everybody. Good. That was to everybody, not to just,
Yeah. Everybody
not to
out
KP.
there, do not rely on KP. Just don't. It's just I
We are not being paid to say this either.
no, it has its purposes. It's great for looking back on things, like you could bring up like the let me see if I can find it real quick, like the Bartels music. Um, let me see if I can find it
The
really quick.
music sheet?
Yeah.
Oh yeah.
Because let's see if
I
I
need to
can
save that.
yeah, let's see how fast I can find it. Probably not very fast, but we're gonna try.
That's okay. We can just rant in the meantime about how useless generally these things are.
Yeah.
Although it is fun in the historical sense, and of course, geomagnetically at least, in terms of any sort of geomagnetic induced currents or drag in the atmosphere, there's a pretty good consensus amongst it all, which makes sense as to why the KP index exists at all.
Yep.
But not for Aurora, because remember
No,
everyone, Swipsy does not predict Aurora.
they do
They
not.
have they have Aurora predicting tools and models out there, and they predict the Aurora, but they do not predict the Aurora. If this sounds contradictory, you're just as confused as I am then.
Yeah. Let's just say they have more important stakeholders that they have to answer to, like aviation, satellite operators, power grid operators, things like that are more dependent on the geomagnetic activity than Aurora. So the Aurora is like a byproduct and it's there. And I think they're trying to work with the citizen science people, like they've reached out, like how can they make it better? Um, so I know that they're aware of it, and it's just not as
They
important
just
as
need to pick a lane. That's all.
yeah,
Don't
maybe
say
that.
they're not going to predict it and they're not involved in it whatsoever, and then completely be involved in
True.
it.
They're like
That
yeah,
seems like just the
maybe they should just put on there, hey, these are tools that we have, but we don't predict this.
which I think
So
is what they're generally doing now,
yeah.
which
So use
helps. But
use at your own discretion. I did find the Bartels music, so
yay,
but
figure that ranting would be
I'll
enough.
show you why the KP index is helpful because this is
Ah, it's so cool.
I believe this should be what yeah, hold on, nowcast between, so it's July. This is basically
Oh, it's
July.
current.
So this you could see you can look at this and immediately tell exactly where there was geomagnetic activity based on these black, like, because like so you have, it turns into a geomagnetic storm right here when you start getting the double five, like the double bars like
Oh,
coming.
so they don't even mark up if it's below a 5.
Yeah, no, yeah, it's
Oh,
like
okay, okay. Well, that makes
this.
sense.
So you can easily pick out like right here, here, and here. There was geomagnetic activity that day. So let's say you're doing some research and you're like, I need to find some um data on a day that where geomagnetic activity was high. You can pick a year, pick a date. This goes back a long time, like long time. I'm talking like the beginning because KP index has been around for a while.
Well, we've
So
had magnetometers around for a while,
yes, for
especially,
a
so
long time.
that's
So
pretty
I've
easy.
looked at these diagrams from like 1950s. Um, so you can pick up data in there. It's like, okay, I need to research this date right here. And then you just go to that. And yeah, so this is why KP is still relevant, still important. But if you're
Won't be going away.
real time aurora chasing or even just aurora chasing at all, it's hard to make a case use for it because it misses a lot. Even the higher cadence KP indexes that we have now still misses things because it is a global, it's a planetary average. So you're not going to get those little nuanced things like this. So
Like, go into one of those darker areas and then tell me where there was aurora within that.
yeah, which there likely was Aurora on most of these days.
To be fair, I'll give them that. Like especially the May 10th, 11th session, that was
Yeah,
pretty obvious. There was Aurora
but
everywhere, but the
but I
idea is you
know,
can't find specifically where or when
no,
in that.
yeah, you can it can pinpoint where big activity happened, but that's it. So, yeah, there's our rant on KP. But these Bartel,
There's going to be one every session, I think.
yeah, these Bartel music diagrams, I just love them. I think they're
It's
very
cool.
they're very poetic. So,
It makes me think of actually, they might have already done this, but there was a study for climate change. Someone turned the global average from like the 1900s to now into notes for each year.
okay,
So higher changes had higher notes, and lower changes had lower notes, and da da da. And then they just play it in a song. I think it was a bass cello, maybe, or bass
pretty
violin.
cool.
It was something big. But then, of course, the tone of it was, would go up and down and up and down, and then it suddenly would just get really high and really high and really high, and it hasn't stopped. But the idea is you can translate the data into cool things like songs.
Yeah, and then it just makes it easier, for people looking at this too, because like you can like again, I said I'm a visual person, so this is very visual. Um,
Does
it's
help.
it's just pretty cool. So anyway, there's our Bartels music. I'll stop sharing on that. But yeah, so KP is okay for certain things, not real time roar chasing or even just I don't know, predicting it. It's hard because it misses so much. And you're gonna miss a lot if you just rely on that only.
Yep. Or if you're saying like this was a KP3 Aurora, like I know there's some people in Alaska that have done that in the past too, and it does make it a little easier when it's a little more. I mean, like Alaska, I think has a decent case for it, but the idea is if you label this Aurora as a KP2 type Aurora, this Aurora is a KP5, that and you're missing a lot, and especially for middle lower latitudes, it's not going to be anything anywhere close to that.
Yeah, it's just not. End of story.
Which again, one every week. I don't think there's going to be a non KP rant on any of our sessions, unless there's a lot of space weather to go over, in which case it'll be
Yeah.
like a comment.
Yeah, it'll just be yeah. But right now we don't have much going on, so we have nothing else really to
Too
talk
bad we
about.
didn't do these in May.
I know. It
Would have
was
been
a
so much fun.
it was a little afterthought, but it's okay.
Next time.
Next time. Well, anyway, that's all we had. That's kind of all I had for the day.
I'm good too.
All right. Well, to everybody out there watching, this is YouTube, so you gotta like and subscribe. I can't even say that with laughing. I almost said the F word on that too.
Honestly, I mean, just keep, if you have to say it, at least laugh when you're doing it then. Because I
Yeah.
agree. It's something that's necessary. And
Everybody-
share in whatever groups you can. Margaret, thank you for being so consistent on that note. Hi.
Yeah. Hello. Yeah, it's funny because every so often we talk about making these more professional, but then I'm like, maybe we'll just keep it amateur hour. Like
I
I
don't
thought
know if
about
that's our tone.
like writing on pieces of paper, like with the signs, like instead of doing graphics, like on screen graphics, it's just paper.
I will
How,
never be drawing just so I can't draw to save my life.
yeah, like how much do I not like doing video graphics? This much. All right. Anyway, I will end this on YouTube and then we will talk again next week.